Hello and welcome back to Math with Mrs. Becker. Today we are reviewing for a calculus mid-chapter exam. Now this mid-chapter exam will cover sections 1.1, 1.2, 1.3, 1.4, and 1.5. Today we will look over the topics that we covered in 1.4 and 1.5. We had a quiz that covered all of the different topics from 1.1, 1.2, and 1.3. So what I suggest is that you review your quiz to cover those concepts. Okay, and we will start looking at 1.4 and 1.5 right now. To determine limits by substitution, what that means is that you can go ahead and take the x value that you are approaching. Remember, this means find the limit of x squared minus 5 as x approaches 0. What that means is you're graphing this function, and as you come in from the left and the right side of 0, what is that y value approaching? One of the easiest way to calculate that is just to substitute. If I put in a 0 for the x, well, 0 squared is 0. 0 minus 5 is negative 5. So the limit of x squared minus 5 as x approaches 0 is negative 5. Okay, let's look at another one. 0, I can plug a 0 in here. So this would be 0 cubed minus 6 times 0 plus 8 over 0 minus 2. Now when I do the calculation, 0 cubed is 0, minus 6 times 0 is 0. So far I have everything as a 0 on the top, plus 8. So that would give me an 8. Bottom, 0 minus 2 is negative 2. Positive 8 divided by negative 2 is a negative 4. So the limit of x cubed minus 6x plus 8 over x minus 2 as x approaches 0 is negative 4. Okay, let's look at another one. This time we want to fill in an x value of 5. So underneath the square root, 5 squared plus 14 times 5 plus 49. Well, let's go ahead and make some calculations. 5 squared is 25. 14 times 5 is 70 plus 49. If I go ahead and I add all of those, 25 plus 70 plus 49, I get 144. And the square root of 144 is 12. Okay, so the limit of the square root of x squared plus 14x plus 49 as x is approaching 5, it's 12. Okay, now one thing, I just really wanted you to see different verbiage. Determine the limit through substitution. That's what we just did. When they say determine it using algebra, you guys, it's the exact same thing. What this is actually allowing you to do is if you end up with something where you cannot fill in the value right away, when they say solve it algebraically, it means that you're allowed to factor, where you can factor the top, factor the bottom, cancel different things. But your goal still is to be able to substitute that in. If you cannot substitute it in because you end up with a negative underneath a radical, or you end up dividing by a 0, then that's where you have a case of the limit does not exist. Okay, let's go ahead and look. Now here, I cannot fill this negative 6 in right away, because on the bottom, negative 6 plus 6, well, that's a 0, and you cannot divide by 0. So what I'm allowed to do is simplify this first. If I take the square root of x squared and the square root of 36, I would get x plus 6, x minus 6. All I did was factored using the difference of squares. The bottom is x plus 6. X plus 6 on the top cancels x plus 6 on the bottom. So now we can calculate the limit. The limit as x approaches negative 6 of whatever you have left. What I have left is x minus 6. Now I can substitute. Negative 6 minus 6 more is a negative 12. So it's the same idea when they say substitute or find the limit algebraically. It just means that you have to remember you can simplify before you calculate a limit. So you don't look right away and say, oh, can't put it in there, limit doesn't exist. You have to try factoring techniques and things that you have learned in previous classes before you can say limit does not exist. Okay, if I go to this one, can I put in a 4? So if I go the limit as x approaches 4, the square root of 4 minus 6. Well, this is the limit as x approaches 4. The square root of 4 minus 6 is negative 2. You cannot have a negative underneath the radical. Okay, that's imaginary. There's no way to simplify this ahead of time. So this is limit does not exist. There is no way to simplify that. All I could do is fill that in. You cannot end up with a negative underneath the radical. Okay, next one. I am approaching 0. Well, I can't put a 0 in right now, but if you look the top, all of those top values do contain an x. So what I can do is go ahead and divide an x out. So I would have x squared plus 12x minus 5. On the bottom, I have 5x. Now what that allows me to do, I have an x on the outside on the top. I can cancel the x on the top and the bottom. Now it's okay if I put a 0 in there because I would have a 5 on the bottom. I no longer would have a 0 on the bottom. So I can go ahead and calculate the limit of this. If I put in a 0, 0 squared is 0, plus 12 times 0 is 0. 0 plus 0 is 0, so I end up with negative 5 on the top. There is nowhere to substitute in a 0 on the bottom. The value is a 5. Negative 5 over positive 5 is negative 1, so we were able to calculate a limit. Next one. I cannot put a 5 in here because 5 squared is 25, and 25 minus 25, well, that's 0. Okay, that doesn't work. So what I have to do is go ahead and factor if I can. Two numbers that multiply to negative 45 and add to a positive 4, well, that would be positive 9 and negative 5. Because 9 times negative 5 gets me to my negative 45. 9 minus 5 is 4. Now the bottom, I can do the difference of squares because I can take the square root of both the x squared and the 25. So this is x plus 5, x minus 5. Well, the x minus 5 cancels the x minus 5. So what I have now is the limit as x approaches 5 of x plus 9 over x plus 5. Now I can put the 5 on the bottom because 5 plus 5 is 10. So I can go ahead and make that substitution. 5 plus 9 is 14. 5 plus 5 is 10. I can simplify the fraction by dividing top and bottom by 2. 14 divided by 2 is 7. 10 divided by 2 is 5. So your limit is 7/5. Okay, here's another one. Remember, there is that property that says if you have an exponent, what you're allowed to do is go ahead and calculate the limit that's inside first, then apply that exponent to the limit. So I'm going to go ahead and calculate this and not worry about the exponent right now. If I put in a 1, 1 squared is 1 minus 4 times 1 is 4. 1 minus 4 is negative 3. Now I can calculate that to the power of 3. Negative 3 times negative 3 times negative 3 is negative 27. Okay, so this is a big idea that is on that mid-chapter test, really hammering out how do you calculate limits. Another way that we can find limits is to look at their graph. The main thing here is to remember that you have to be able to approach the same numerical value coming from the left side of the x value you're looking for and coming from the right side. So if I am trying to find the limit as x approaches 0, I have to approach x equals 0 from both sides, and notice that yes, they are approaching the same value. That y value is a 0. So I do have a limit. Now this says coming from the left and the right to the 1. They're not approaching the same value. There's a big space there. So that is limit does not exist. They have to approach the same value coming from the left and the right. All right, one page down, troops. Let's keep going. Use the graph. Visuals are really, really big here. Use the graph to determine the following limits. If I'm going to 0, well, if I'm coming towards the 0, they're not going to the same spot. There's that big space. So limit does not exist. Negative 2. Look at this is going up to positive infinity. This is going to negative infinity as you're getting to negative 2. So limit does not exist. 4. As you come to the left and the right, it's going up to positive infinity. You cannot have a limit equal infinity. So limit does not exist. So those are examples of where the limit does not exist. On the test, you could put D, N, E, does not exist. Okay, totally fine. Let's look at another one. I just want to make sure you have a lot of visuals in the study guide. -1. Oh, here's -1. As I'm coming in from the left and the right, it is approaching the same value. That value is a 4. 3, +3. Here it is. As I'm coming from the left and the right, yes, it is approaching the same value. That y value is a 6. -4, as I'm coming from the left and the right, hey, not even close. There's that big space, so limit does not